Okay, in this video what we're going to do is set up the Newport KPX094 lens, and then later we're going to use that for the sweat model Chromatic Corrector, but we're just going to show the lens now. Now this is Zemax 12. There is the Zemax 14. I'll be using Zemax 12 for the demos. Some people are using that instead of 14 at this point. I will switch to 14 if anybody has a real problem with 12. So anyway, 14 is just a little bit more full-featured with respect to the features that you have up here and how you interface with things. But basically it's the same kind of button tools that you use. So what we're going to do first is just load in the lens. So here you just go over to the lens button and select lens, and you go to, I think it comes up with this one, this company here as a default. So you go down to the Newport, and then you select the lens KPX. Let's see, for the example, we use 094. There it is, and you just load it in. Okay, and close that, and there it is in the lens prescription. That's the radius and the thickness and the glass. And to show the lens, we can do the layout. And what I like to do with the layout is change it so that I see the rays coming into the lens. It's not necessary that you do that, but that's what I do. So what you can do is insert a surface here. On my computer it's function insert. It's just the insert key on your keyboard, and we'll just choose a thickness of 10 millimeters there in between the lens, and then you can update your drawing. All you have to change your settings so that the first surface that's displayed is the surface 1 over here that I just inserted. And there it is. So there's a little bit of collimated light coming into the lens. And then if you do the spot diagram, you can see what it looks like. Now here, this isn't exactly the display that I used for the class, so I'll show you how to change that. You just go to settings, and I use the dithered distribution of rays and a plot scale of 250 microns. So just do that there, and a ray density of 20. And then the other thing that I did is show area disk on there. You can't hardly see the area disk, but it's really small right there. It's that little round circle down there. Okay, so that's what the rays would look like, the ray paths intersecting the image surface down here, or the focus surface, the way it's set up. So one thing you'll notice is this only one wavelength, and it's the wrong wavelength, so let's go and change the wavelengths. Let's see, we need for our demos, the green was 587.6 microns, the blue was 486.1 microns, and the red was 656.3. I'm sorry, microns is 0.5876, 0.8. I'm sorry, 0.4861 and 0.6563. Okay, now we can just update, and you can see that that's pretty bad. In order to optimize the focus distance here to get the best overall combination for the 3 wavelengths, what we can do is change this last surface here, the thickness between this planar surface here and the image surface, to a variable. And the way we do that is just click your right mouse button, and instead of marginal ray height, put variable, and then OK. And now what we're going to do is build a merit function. This is what's going to, or an error function if you want to call it that. We're going to go into editors and merit function, and that comes up as a blank. What we're going to do is load a default merit function. So go under tools, default merit function. RMS wavefront centroid is fine. I like to use just max out the number of rings. I think the default is like 3 or 4. And the arms, go ahead and set that. I mean, it depends. It's a trade-off in time here, but this is such a simple configuration. That's fine. It's way overkill for what we need, but it's good for now. Okay, and that'll come up with this list of merit function items here, and it'll take the root sum square of the differences for the total merit, the error, and that'll be what is minimized. Okay, so that's working on the RMS wavefront, and you can get a picture of that by selecting the OPD button, and you can see that here then in the X and the Y planes, and there's the 3 wavelengths. So we're looking at this total scale from here to here is 50 wavelengths of departure. That's quite a bit of departure. So let's see, now all we have to do is do our optimize, and we can see that the default merit function, or the current merit function, is around 4.3. Just do 5 cycles. Only one variable. It's going to optimize really quickly. Then it bettered by a half, and then we can just update the drawings here and see that now we're down, you know, from here to here now 10 waves, where this won't change much. You can see this change a little bit out here. You can see how that's what we had in class then to start with. And then that's it for this video.